Okay, so I've been looking for a multimeter that has output and software so that I can display the measurements that I'm taking on the screen while I'm making YouTube videos. So the first thing that I did, I bought this OWON multimeter, and it came with some software that you can kind of use with OBS Studio, and in the top hand corner there you'll see a black box, but I haven't connected it yet. So this is the software. Let me move it around a bit so it's not. And I find that all the Chinese companies that make these things, their hardware sometimes can be okay, but their software sucks. And this is one of them. So this is the software that came with it, and what will happen is you got to go to Control, Connect, and then very unintuitively it comes with a USB cable. So you would think you could connect it via USB, but no. You have to click on this thing here via COM and USB. Then after you do that, after a little delay, it'll come up with the current COM ports that are defined on your system. And you kind of have to guess which one it is. If you select the wrong COM port, it'll just crash. The whole thing will just disappear. It'll say nothing, it'll go boom, it's gone. So that's a bug, and they should fix that, but they haven't. So I happen to know from already trying it that it's COM7. So I say OK, and now it has taken complete control of the little OWON multimeter. And as you see, I have told OBS Studio to pick up this section here of the of that screen, and you can see it at the top hand corner there. And the thing I didn't like about it is the you know, it has stuff going on there, but this trigger thing all the time, and it has, you know, the nanofarad is very small, so I wasn't entirely happy with that. And the second thing is with this multimeter here, it is tediously slow in everything it does. Like for instance, I'll hook up a capacitor over here, and you will see it's hooked up. So we're waiting. Ta-da, 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 ta-da. Of course, you can, if you know the capacitor what it is, you can change it, take it out of auto range, that'll speed it up. But still, I don't really want to have to do that. As you can see, it's like it went to overload for a second. Now it's decided it's actually 2,200 microfarad according to the capacitor. But you know, electrolytic capacitors are notoriously not very accurate in their. Alright, so finally it has decided it's 2089 or 2.089. It's still counting up millifarads, so that is way slow. And similarly, if you take the thing into continuity mode, and even when you're measuring voltage, it is just really slow. So when I put it into continuity mode here, and it's supposed to beep, but if you just touch something, it's too slow. See, it's not beeping. You have to hold it for a while. I guess, you know, you can get used to that and just be a bit slower, but still it's not you know, if you're going to a circuit, you just want to go, you know, be quicker with it. And as I say, similarly, when you are measuring voltage with it, it's slow. And so I wasn't quite happy with that. And So I've been looking around what some other people are using, and I was watching this Louis Rosman or whatever his name is. He has an on-screen display, and he uses this BK precision multimeter. So I thought, well, I'll get one of those and I'll try it out. So I'm actually done a video on unboxing it and kind of looking at it, which I will insert in here in a minute, that you can see the funny things that happened. For a start, it comes with a little manual which has absolutely no information, and not even online, on how to actually set up this software that came with it. The software was very old. It's from like 2004, so it's written in Visual Basic, I believe. And it doesn't come with drivers. You have to kind of work out yourself by going to the device manager in Windows and see that it is looking for a device driver and you don't have one. So you have to do a Google search and you find out there's a company called FTDI that has a driver, and then you have to install that, and then it still doesn't work because you need another driver, and so on and so on. But finally I did get it to work. This is the thing here, and it is also quirky. Now I've got it set up for measuring capacitance, but you will see that it is a lot faster than what the... So let's go to capacitance mode, and I'll hook up the capacitor. Now, multimeters, when they measure capacitance, are not like... Oops, the thing came off. They're not like LCR meters. The clip came off, so it was actually reading it already. See, it's a lot quicker. It only takes a few seconds. So that's passable. So another quirk with this thing is, which I've never seen on a multimeter, is that when you measure capacitance, you actually have to put it in the microamp milliamp socket. As you can say, CX plus, CX minus, which is an inconvenience. But when you put it in continuity mode, see, it beeps straight away. Oh, I got it. So it passes. So this multimeter is actually, it's not bad. I kind of like it, but I'm not a great lover of these rotary dials that traditionally they put on these things. I much rather like the buttons, like you will see on that on the OWON one. See, no rotary dial. You can just push the buttons. I like that a lot better. And that's just me. But anyway, so I thought, well, it came with software, so I installed the software. So let's bring it up. So this is the software that came with the BK Precision one. There's no documentation with it, so you kind of have to guess how it works. And some of these features here I wouldn't use, but basically, if the drivers are working, it actually recognizes that the COM port it's running on, and if in fact you don't have to do anything, it will just start. Okay, so in order to make this work, it came with this little cable here, optical interface, and you have to connect it to the back. Alright, it is connected. So, and then after you connect the cable, in order to make it work, you've got to hit this RS232 button. And so let's have a look at the software here. Alright, so this software here recognizes the COM port that it's on, and I've got it on COM2. And I had to do it put it on COM2 because it can only work with COM ports 2 to 7, and I have other things connected to this PC, and the driver originally wanted to be COM10, and you couldn't make it work. Anyway, this setup button, communications, yeah. See, port 2 to 8 is all it could handle. Any case, so if I connect the probes together here, it is working. But in any case, I don't like this display here to put on my videos, and it has stuff there that I don't care about, like this little bar over here and the colors and stuff. None of that is configurable. So what I did was, let me turn that off. I contacted the BK Precision customer support, and they sent me a few pages of a document that they have internally. Obviously, this is page 13, and it actually communicates the communications protocol, and it actually sends, the device actually sends 11 bytes. There's a range byte, then there's digits 3, 2, 1 and 0 of the value. That's four bytes. There's a function byte, a status byte, and 2 option bytes, and then it's delimited with carriage return line feed. And then they show over here the codes for the function and the codes for the range, and the digits. It's just ordinary ASCII code, like 30 hex is 0 and 39 hex would be, hexadecimal would be 9. There's the status, the option, and so on. So I had a look at all this stuff, and I actually did a dump of the actual data that it sends and what it means. And so then I actually created my own little document here, which is more clear than the one that they sent me, and I used this document in order to create my own software. So since I am a retired software engineer, I'm familiar with Microsoft Visual Studio and C#, so I decided to use that. So I created a WinForms application with the latest version of the .NET framework, version 7, and I created a little form over here with the fields on it. That they're all actually labels, or every single one of them, but I want this to show at the top of the screen, and didn't want a border on it and stuff like that, so I had to actually create some code here. I put a little button, so actually it's also a label, but it behaves as a button that you actually, when you click on it, you can actually drag the window to different locations. And I put this little hamburger menu thing here, which is button start, and I put a special character on that, and that will bring up this actual menu. It has, you can start and stop it, and there's an about box, and I was lazy, I didn't create an extra window for that, so I modified the about box and put a little COM port selector on there, which you will see over here. I put a little combo box there, and you can select the COM port, but it'll default to the one that it's on. Nothing special there. And I put a timer on there, which actually has an interval of 100 milliseconds, tenth of a second. Reason for that is that if you look at the code, this is the code that is behind that main form, that one there. And the one thing that you will, let me get rid of this box there, but a Windows operating system. Underneath it, it works with a messaging system, but at the top of it, with .NET framework and what have you, everything runs, many things run in different threads. And the front end, the UI, the one that you see over here, it runs on one thread, but if you are connecting to like a COM port, a serial port, you want to be able to collect the data on a different thread so that it doesn't lose any data. A little bit like an interrupt driven system, if you like. So, but then if you are collecting the data on the other threads, you can't display data because you can only display and access the controls on a form during the UI thread. So you have to run through hoops in order to do that. And that is what the system has delegates for and events. So you create a delegate and you actually pass the data to it that is received, from the background thread, and then you have an event that says data received, which actually calls that delegate with the data that was received, so your COM port read line, and the delegate for data received puts it in a place. In this case, I created a special class called collector that actually collects that data, and it's actually like a queue, first in, first out queue. So we will be able to find that data there from the UI thread, and that collector, we'll have a look at it in a second. It's a special class that actually allows multiple threads to work with it. And when the timer ticks 10 times a second, it says, hey, decoder, do you have anything for me? And if the decoder does, then we pull out the fields that you saw earlier that it sends, the actual value. The decoder already has, of course, decoded the data, the applied bit masks, so it has a value for this AC/DC, the value for the mode, the value for the status, and it has units, prefixes with postfixes, like K for a prefix and hertz maybe for a unit and so on, and then some more stuff there. So if we look at this collector class, I put all the information in here as a comment, basically a condensed form of what you saw on that paper that I created. What the actual range byte means, and what the value and the function and the status, and the option 1 and option 2, how they should be interpreted. So here we have this queue, and you can see it's a concurrent queue, and it's just a special queue class that the .NET framework, I think it's since .NET 5 or something, they included those things because multi-threaded and parallel programming and everything became a thing, and they created those things in order to make that easier. So this concurrent queue, it's a fast first in, first out stack, which is what we want. We want the data to come out in the order that it was received. and it actually deals with the fact that a thread might have to have a lock on it while you're putting data in and taking data out. Without that, you could end up with a situation where the background thread is trying to push data on the queue while you are trying to read data off the queue, and things would get terribly out of sync, and you would get data corruption. In any case, and then I added a few little methods to it, count like how many items are in the queue and clear the queue. And this is the collect method that you saw being used on the main form. So it just actually collects the data, sticks it in temporarily in a raw data variable, and it is looking for delimiters. Of course, that CRLF thing on the carriage and line feed on the end, so that it knows it has a whole packet. Anyway, these are all local functions, methods to get that data out. And here's the get packet that you saw being called from the main form. See, oh no, the get packet is actually fetched by the decoder. I'm sorry, we'll get into that in a second. Anyway, and some enumerators so that we can enumerate through the whole thing one at a time with a for each command in C#. So this is the decoder. This is actually the one after the collector has collected the bytes and stuck them in this queue. Then they have to be decoded into values that can be displayed that make sense to a human being, because many of them are bit masks. So I created yet another class called BK390 data, which is only used internally. It's just a convenient place to store the actual data. All the data that says code and value string are the raw data that comes from the serial port, and then over here there's the decoded data and the number of decimal places, because the value that comes in, the value string here, is just 4 digits, doesn't have a decimal point in it, and it's got leading zeros as well that has to be removed. Anyway, so we've got a mode, a status, a sign, whether it's negative or positive. Also, that's not part of the value. You've got to detect that from this bit mask of one of the options, I think. And this then is going to be the actual value, just the 4 characters. There's the prefix and the unit and the postfix, and as you saw those being used. These are the pre-digested values that can be displayed, and these are the bit masks. So function voltage is 3B hexadecimal, 59 decimal. I didn't put those there, but just as an example what that means. This is binary for B for binary. 0011, that's 3. 1011 is B, and so on. So these are all the functions that it supports. Bunch of functions there that this multimeter does not support, but they were in the definition, so I put them in, but I commented them out. And the status byte, similar here, the battery symbol when the battery is low. I don't care about that. I don't want to particularly display that on my form when I'm using this thing. So there's values over here, bit masks that are applied, the actual location of these bytes in the actual data packet. So the first one is the range byte. At position 1 is the value, which is actually 4 bytes long. That's why the next one is 5, 6, 7, 8, and so it goes on. And then some local private methods, functions, in order to extract data, extract byte. Over here, again, these are actually private things used internally. This is like it has the, as you saw, the byte range is 0 and it's 1 byte long. Byte value was 1. It's 4 bytes long. Just a place to define the fields, so we don't have to have these numbers as hard-coded numbers in the rest of the code. It's just in one place. If you ever have to change them for a different model, multimeter or whatever it is, I believe they got a 393, which is a different model and has some different features, so you'd have to make some adjustments to that if you had one of those. Okay, so this then is a method here to format that value, because remember the value is only 4 characters and it might say 0010, but it actually means 0.1 or something like that. So we pass in the number of decimals that it's supposed to have. We pass in the sign, so we can add a minus sign to it if it is negative. And this is what it does. It'll add the sign, and the sign is either going to be a space or it's going to be a minus sign dash. And if there is no decimals, then it uses this special formatting code. See, no decimals, 1 decimal, 2 decimals, 3 decimals. And if somehow we end up passing garbage in there, shouldn't happen, but we will just leave it alone because we don't know if decimals was anything but 0 to 3. Just so it has some way to deal with it. This is the decode function, and this is kind of long. It's like a case statement, and it's for the different, if it's voltage then do this, if it's current do that. And there's 3 different currents: microamp, milliamp, and amps, ohms, continuity, diode. This is actually frequency, but there must be a model of this thing, maybe used for automotive use or something. As you see later on when I include that little videos when I unpack this thing, on the box it shows you about 3 or 4 different models, and one of them must have an RPM function. So it's actually, the code is actually, I put the code in, but it is this model I'm using, 398, it doesn't have that, so this will never be called. Could actually be commented out, I guess. Capacitance, temperature, and some extraneous other values, like if it is it in range or auto mode. As I said, the sign, if it's negative. There's some features there that has, you can say, push the min max button, and then it actually records what the minimum and the maximum is over a period of time. If you are in voltage mode, you can hit this VA or this Hertz button rather, then it comes up with volt, amp, Hertz. So if you are measuring, it's kind of a neat feature, I think. If you're measuring a voltage like from a power supply, you can hit that button, and if there's any ripple there, it'll tell you what it is. And you can then use the min-max thing as well to actually, if it's in current mode, to how big the ripple is, how many millivolts or whatever. Anyway, this is in AC or DC mode, and auto power off, not very important. So that's it. That's all the software, and we can actually run it now and see what it looks like. I've actually run it over here, and you can actually see it on the screen here. You can't see the edges of the window. As I said, I put this little button over here so I can move it around, and there is a menu over here, and I should be able to say start, and there it is. But I'm looking at the other screen now, so let's turn that off, and I will select it in OBS Studio the way that it will show up in the videos there. So there it is. This is how it will come up on the screen. Of course, I can relocate it. It's put it on the other corner there. So when I connect something to it, yeah, I got some components. Here's a resistor. .88 kilo ohms. And I can put it in continuity mode. I can put it in diode mode. Here is a diode, a really big one. This is reverse, so it shows nothing. And this is forward, 0.504 volts. I have a bench power supply here, and I've got it set for this little bench power supply. I got it very accurate. It's got a digital display on it, and it's set for 1.01 volts. And this BK is complaining because that's not on voltage. Turn it on, and it exactly says 1.01 volts. So it seems my little bench power supply and this multimeter are completely in tune. It appears to be very accurate, so that's a good thing. And the one thing though about it is this particular model, it does not have true RMS capability, but that doesn't worry me because it will work when you give it a clean sine wave. But if you are measuring some sort of signal that is not a pure sine wave, it won't give you the real RMS value, but that's just a feature of it, and it doesn't worry me particularly. Oh, and also let's have a look. Put it on AC voltage. So I've got it connected to the power supply, which is connected at the output, and it looks like the power supply has 1 millivolt ripple, which is actually very good. It's a good little power supply, that. Alright, so that is what I have, the software that I created, and that's what I'll be using now in my videos. If any of you are interested to see more about details about the software, as far as I'm concerned, it's still a beta test version. I have to do a little bit more testing how it interacts while I've got other COM ports running and stuff like that. But if anyone's more interested to see that, or if you would be wanting to have software like that or something like that, I can probably put it on GitHub or something. But stick it in the comments and make sure you like and subscribe. But that is how it went. Now next I will include some snippets of the video when I first got this thing and the funny things that happened, you know, when you install the software and it didn't work and all that kind of stuff, and I had to find drivers for it just to see in the real world actually what happens when you buy these things. This thing is actually made in Taiwan, I think, and the Chinese, they are just not good at software. And I think that BK Precision, they've discontinued this thing now as of January. I've noticed they must be getting new models coming out. can also put it on temperature here, 20, 25 degrees, 24, 72 degrees Fahrenheit. That's actually a useful function of it as well. All right. So I bought this BK Precision multimeter here, which I was told has better facilities for displaying the measurements on the screen. So we're going to try that out. I have not looked at it. I have not opened it up yet. So I got the box here. So let's have a look what we get. Some strange cable here with a little, looks like a light emitting diode or something. Optical interface USB-A. We'll have to find out what that's all about. Temperature probe. Little probes. We'll have to look how good they are. This is the multimeter itself. A little manual. Instruction manual. Okay, well it appears to be in proper English, so that's a good sign. I'm not going to put this thing through its paces completely, but just to have an overview of it. A little brochure here with semiconductor test leads. I wish they would have printed the manual on nice paper like that instead of this coarse stuff. Certificate of compliance. Okay, very good. And it's got a CD-ROM, PC utility software for Model 390A. Seems to have a sticker on there which is off-center. That's going to make that thing vibrate, I'm sure. But we'll try it out. Okay, need some scissors. Here we go. Okay, seems to have a battery in there already. Peel off the little thing off the screen here. Okay. It's got a little stand, and I see on the back there some sort of oh, look at that, a socket, and this thing here looks like it'll plug into that socket. Yeah, there you go. Seems to have an optical interface with a USB cable. I'll plug that into the computer. It's on the computer display there, setting up UART or something like that. I'll probably find out when I put the CD-ROM in there that I wasn't supposed to do that, but we'll find out. Anyway, I'm going to stick the CD-ROM in the computer and see what is on there. Okay, so this is the files on the CD. Well, I guess we'll just run setup. So let's have a look how this thing works. Setup, communications. Unfortunately, all the little windows are coming up on the wrong monitor here. Well, let's go to help because there is contents. Can't find HCM File Explorer. This software was written for Windows 98 and 95, according to what I see in the thing. It's old, so there's no help, and it says it's going to be on COM5, but I don't believe that that is going to be correct. I would say, from what I know about this computer, COM8 is new, so let's have a look if that works. Oh, it's got a button that auto setup. Let's try that. That's auto start stop. That's not what we need. Well, that was an experience that was a little bit less than desirable. I thought that BK Precision would have had a better situation there. So what I found out that is that this particular meter is actually discontinued as of January this year by the sound of it. And the actual software that comes with it was originally written in Visual Basic as far as I can tell. And the last time that I put it on the website was 2006 or something like that, 2007. And it is totally out of date. It actually mentions Windows 98, and it is, when you install it, it will not install the drivers. So I had to do some Googling on the driver. Came up at an FT232R, and I found out that there's a company that actually makes, I guess it's like a chipset or something to convert USB to RS232, and then I installed that, but then another driver came up, and I installed that as well from the same zip file that I downloaded from the company that does the drivers for that. So then they started working, and then I tried to run it, but it still didn't work because I have a lot of stuff on this computer, logic analyzers and all sorts of things and drivers and so on, and they've all hogged to the COM ports. And if you look at the device manager here, it's not totally obvious because only the ones that are currently connected are shown here, but all the COM ports from COM3 to COM9 were reserved by other drivers and things. And this particular software here, when you go to setup communications, this is actually, that number here is actually the COM port number, and it can't go any higher than 8. So it couldn't even connect to COM10, which is where it was being installed. So I went in manually and into the device manager and actually assigned COM2 to this particular driver, and now it appears to be working. I can change the selection here, and let's have a look. Well, I've got, let's put it on resistance mode. I've got a resistor here. (98.8 kilo ohms). I don't like the display very much with this dark color in the background, but I guess I haven't been able to find any setups for that. But now when it comes to OBS Studio, I can just actually change the size of this window. Is that window resizable? Apparently not. Try to resize it, it just goes, yeah. But in any case, I can use OBS Studio just to cut out this little bit here and put it on the top of the display. So let me do that. Okay, so as you can see, I have it set at the top of the screen here. I can make it a little bit bigger there, like that. So I guess that will work.